Thank you very much for coming, and I would also like to thank CyberCamp organization for having me here another year. I hope you will enjoy this presentation. I would like to tell you what we're going to see in this presentation. I don't know if you are all related to the industrial sector or the electric sector, but we're going to see assets, communications, and some regulation that affects this sector and can make us understand better how the project developed. We're going to see the electric sector. We're going to know what attack-taxonomy is and how to incorporate procedures and techniques. I think there have been some presentations on this topic, so I can help you understand them better. We are going to talk about the CAFFEINE framework, what it is, and how to use it at the industrial level. And we're going to see threat modeling, taking into account all the information. This is who I am. Sere has already introduced me. Here you have my LinkedIn account, and I will be glad to answer any questions you may send me. To start with, the project is the result of a master's degree final thesis, whose name is Stage Framework of Attack for the Electric Sector. The name doesn't match the framework, but we will see why afterwards. This framework was the result of a need of certain sectors, such as the electric sectors, to have a regulation, also from tasks, from red team tasks and attacks modeling. The last attacks that have affected more the industrial sector were aimed at the electric sector, so it is a strategic sector, and it can also affect scooters, electric cars, and devices which work with certain batteries, and that can be a problem. Or another reason why I chose to carry out this project was due to the Cyber-EU framework, which has to be complied with in the financial sector. It is a set of rules for red team applications, how to interact with the financial environment. Some sectors require very strict regulations, so you cannot carry out some testing. Testing has to be agreed on with the client. This happens in several sectors, such as the electric sector. Another reason to use the energy sector, and especially the electric sector, is the high number of attacks that have been detected. There are several facts based basically on the fact that some companies are investing on development. Some experts on this subject can do some research on vulnerabilities that affect devices located in electric substations or in one of the stages of the energy supply. We're going to see some of these devices in order for you to understand better what I'm talking about. In order to place us into context, there are several parts in the electric sector. We have the electric power plant, which generate electricity coming from windmills, dams, and so on. And then there is a second stage of transportation in order to convey electricity to strategic points. Then we have a substation. Some of them also have a transformer in order to supply energy to the customers. And then we have this substation of distribution, which is the one we are going to focus on. Finally, we have the marketing stage, the one we are more familiar with as consumers. We have smart counters and meters and other devices that carry out measurement. So what's the objective of the CAFFEINE framework? The idea was to create a framework for the electric sector in order to have some rules to avoid attacks in the production stage, which is a very strategic point both for the electric and industrial sectors. It is quite complicated to tell somebody from a power plant that you're going to enter and you're going to handle some machines. They want to know what you're going to do. Another objective is to boost, to promote the taxonomy, the Cyber-Attack-Taxonomy. That's going to be different from all the presentations devoted to taxonomy. We need to provide some regulations for this taxonomy. And finally, I want to provide a set of key steps in order to execute red team actions in a production environment, to tell the client what actions you're going to carry out and what attacks they can be affected by and how to avoid them. We're going to see what kind of attacks can happen at this stage. So we're going to start talking about the electric sector, how a substation works and how some devices work, especially the part of the control unit. It is not reflected here, but it is quite important. We also have smart devices, IEDs, which enable to open and close faces. And you're going to see a picture which explains what an IED can manage. I have a substation and it can supply energy to some households. This is the general concept. We also have the part of HMI, the human-machine interface, where an operator can visualize operations that are developed within the substation, or it can be a global HMI that interacts in more than one process, and then you will have several operations on the same screen. Some stations are called remote stations, RTUs, which are devices that enable to execute control actions, although this device is starting to disappear due to the presence of IEDs. There are devices at the network level, such as switches, WLANs to segment the network. You can also have a small SCADA, local SCADA, in order to see how the process interacts. And in the stage of visualization, you also have them in the control unit with a firewall, if there is one, or with some network devices. And then we also have the SNTP server, because in the industrial sector, timing is quite important. As for communications that you can find in an electric substation, you have simple values, GUS, and MMS. All these protocols, GUS and sample values use multitask, which means, I don't know if you're more familiar with broadcast, but this means that you can send a packet to one address and all the devices in the network are receiving that message, that package. This also incorporates vulnerabilities. Some manufacturers hadn't implemented correctly their devices, and once you re-inject packages, all those packages arrive at the whole network. So in the end, you can have a denial of service of all the devices within the same station. On the other hand, we have the IEC 104, which is a protocol of communication which enables you to do some reading, to execute commands, to close or open devices. We are going to see a demonstration aimed at this protocol and to another protocol, which is the NP3, that is a protocol very used in America and affects the electric sector. Probably in Europe, there are some devices that can be compatible with that protocol. Here there are some filters, and some of them can let us detect some attack with some tools, such as this one, 104. ASDU type ID equal 45. This enables you to detect single commands. So if I detect a command, I can open a switch so I can let the electric current pass. In some devices, this means to supply energy to a whole city or not. At the regulation level, which is always more tedious, we find the 27019, which is a standard that affects mainly the energy sector. You have a specification of the control and monitoring systems within generation and transmission stages. We need to take these regulations into account when carrying out some actions, when accessing energy substation. We also have the IEC 62351, which is a regulation on how protocols work. I'm always talking about TCP protocols, maybe in some other layer. And also we have the 618050, which is a GUS, and so on. Finally, we have the set of standards IEC 62443, which incorporates controls and best practices in order for industrial entities to classify their assets by segmenting the network and by ensuring them. After this introduction, I would also like to comment on incidents detected at the industrial sector, specifically at the electrical sector. In order to be more in context, we're going to start talking about the framework and so on. In 2015, black energy, gray energy, black energy managed to block out a substation, basically because this attack sent single commands in a repeated way. This was the end of the incident, but it was first detected in 2007. There was a malware which was distributing denial of service attacks, and then it started to evolve this malware. There was a second version in 2010 with more functionalities, such as rootkit and so on. A little bit more complicated. The last version of this malware was in 2015, and it affected a Ukrainian substation. And then in 2014, there were the black energy light and the black energy big. One had a device in order not to be detected, and the other had some other variables. In 2017, there was modular malware, one of the most complex ones, which enabled to attack using industrial protocols such as IEC 104 and 101. So it disabled legitimate communications. IEC 61850, OPCDA, and so on. It had a system to discover devices, and it used Siemens vulnerabilities in Cyber-Attack devices. They were starting to incorporate some devices not to be detected, as all the malwares were incorporating at that time. Finally, we have the gray energy in 2018, which was targeting industrial objectives, industrial targets. So its main objective was espionage and recognition, and it affected workstations that executed SCADA software, quite important for the process, and it also affected servers classified as essential systems, which were rarely turned off, only on specific tasks. Obviously, if you find this malware in this kind of assets, you may think that the attackers know where they're going and what they can do once they reach their target. The data stayed as they were, but it didn't affect, in the end, the operation of the process. Now we're going to talk about attack taxonomies in order to distinguish between the CAT part and Luken-Martin part. What are their differences? An attack taxonomy is a set of stages in which you can analyze the behavior or the modeling of an attack. It is like in-depth analysis that you can carry out with equipment, and you can know what actions were taken by attackers so that you can learn from them and use it in defensive systems, blue team systems, and in red teams in order to simulate. The difference between emulate and simulate is that when you simulate, you try to do more or less the same attack, and when you emulate it, is that you are doing it exactly in the same way. As for Mitre matrix, it incorporates the impact technique. We have tactics and techniques. And the technique is what has been done. We will see that in depth later on. I just wanted to talk about the Lockyer-Martin. We have seen several models based on the same one, say based on cyber kill chain. Due to the lack of some features, I opted for CAT, but it doesn't mean that we cannot use caffeine in that case. I would like to explain how CAT taxonomy works. Basically, it is a methodology. You may be a little bit lost, that's why I'm going to tell you what the environment of CAT is. So, as for strategy, is what a group of attackers want, and then how are they going to get it? Then we have tactics, techniques, procedures, and tools, and then we have the evidences generated during or after the attack. You can have some artifacts that detect what they have done at the host and network level. And then we have caffeine, whose objective is to generate specific tactics and techniques for the industrial sector, especially for the electrical sector in substations. And it is here where you see the grain of coffee. And it also wants to develop tailored tools or tools from other manufacturers. So how does the taxonomy work? I guess that the Lockyer-Martin is more known because it is used by a lot of people, but in CAT taxonomy there is an analysis of threats, so it means people are doing some research on the target. There is the macro-intelligence, the micro-intelligence. There is a target profilage. Attackers do some research on their target, how they're going to attack. They analyze processes, technology, and people who are the most vulnerable ones, because it is more difficult to create a magic malware, for example. Then we have the commitment part. We will see this status in the modeling of an attack. In the commitment stage, you execute necessary techniques to generate breaches, security breaches within the organization. Then we have the infiltration part. So to take advantage of those security breaches, they may load some tools and they lay the foundations for the attack to be executed. Then we have the persistence part. When they are analyzing a target, they usually come back to review what they had known. This is quite complex because somebody is within your network and you don't know they are there. That's the main complexity. Today, it is quite difficult to carry out these kind of actions without being detected. Then we have the internal recognition part. I am interested in knowing who is around me, what my main targets are. For example, let's imagine I'm attacking a provider who provides support for my target, one company. So I know this provider provides maintenance to this company, so I may prefer to attack the provider because he has some permissions, such as using USB sticks, for example. Then we have the lateral movements, so moving from system to system until they reach the main target, and then it is then when they execute the attack, they perform the attack. This slide wants to explain to you why I chose CAT taxonomy. This taxonomy enables you to create loops. It is not a linear pathway. In the cyber kill chain, you may think it is not as linear as it is thought to be, but that's why I prefer to use CAT. Then it shows all the stages in a coherent way. This is the strategy part, the main difference between CAT to CKC, because CKC has no strategy and CAT does have it. So I can know in which stage I am. I can use the Mitre matrix based on this taxonomy. As for the arming part, it doesn't allow a defensive strategy that can be used by blue teams. As for CAT, I said it has some strategies and it can adapt to TTPs. What does this mean? This is quite important because CAT doesn't exclude Mitre matrix. It uses it. The idea is to use all tactics and techniques because it is better to work in the same direction and not everyone on their own. So that's basically the reasons why I chose CAT taxonomy. Now we're going to see exactly what caffeine is. I changed the name because it was more aimed at the energy sector, so cyber-attack framework for energy infrastructures. It has a cool name, and I love coffee. That's why I named it this way. The tactical part's name is CAFFEINE. Now we're going to explain the difference between tactic and technique. It is the way, the method used in order to reach a specific target and which provide support to the strategy. The tactic is the way that task is performed. And then we have the tool part. There can be tailor-made tools or tools which exist already in the sector. How can I represent all these? Well, here we have the CAT stage, which is the execution of the objective, the tactic, which is a trick to the control center. How am I going to use? I will use modification of parameters through industrial protocols, and then I can use some tools such as simulating communications with the remote unit using escape methodologies with IEC 104 or simulating communications of RTU in order to trick the SCADA system in order to interact with the master. Okay, now that we all these exercises are not going to be in a substation. Let's imagine a substation which is supplying energy to a city. You have the compliance part and so on. So how can we do it in order not to have any impact? First, you need to have some strategy, because you can have discharges within the substation or nodes balances. Now we are in winter and it is colder in the north than in the south, so I can supply more energy to the north and less energy to the south. So it can let you enter a substation and carry out some actions that you have agreed on with the client, because you have already explained to the client tactics, techniques, and tools that you're going to use in accordance with the regulation. Now I have a demonstration in order not to get you bored, so I'm going to show you this demonstration.
No sé si lo estáis viendo ahí. Voy a intentar a ver si no se está reproduciendo con el lo que faltaba. Bueno, pues mira, vamos a hacer una cosa. Lo hago aquí y os lo voy comentando. No sé si lo podéis ver bien.
Are you able to watch it properly? So this is a demonstration. I have here an electrical substation that is interacting with the protocol that I've mentioned before. The protocol DNP3 that affects especially America. So here I have a screenshot. I have a master and a client, and here you can see how there is normal communication. This is local host 57001. This is a closed environment, such as an industrial environment. Inside these communications, there are some responses by the master and the client. There is some interaction. I need to know some parameters in order to see how the process is working. And also I want to send some control commands. So what are we going to do right now? We're going to try to use fuzzing techniques, with means that we're going to use different parts of the protocol in order to start changing values, so that there are modifications and many orders are sent. So here we used an IHIS fuzzer at the level of the NP3. And you may send things that are well or bad implemented, but at the level of the fuzzer level, you just want to generate an anomalous state within the device. So it makes sense sending strings that are wrong. So we've sent these wrong strings. And how am I going to detect that someone has accessed and has used a fuzzer in order to interact with a device that may be active in my environment? Well, we're going to use a Kibana. Kibana is fed mainly by a probe, by a sensor that sends information. So this is an LK and a Kibana. One receives the information, the other one takes that information, sends the information in a coherent way and with a format that may be understood by Kibana, which is the tool that's going to do the different steps. And then in the panel, someone may interact and choose different filters. I don't know if you've been able to see it. But here, if you click the zoom, there are more filters that I don't know that if you can see from there. And there is also a CAFFEINE technology being used, and this gives you the chance to access specific traffic screenshots that may be of interest to an analyst that may have tested some weird traffic or any other type of problem within the network. So here we have the strings, and for example, this can be downloaded in order to visualize it with a different tool. So if you download this, you can see that there are wrong strings. And something else that I skipped before, and I think it's quite interesting, is that here we have a dissector called BRO that allows you to interpret the different strings, and there are also some connections in which it says BROE. These are weird connections. So the tool is already detecting that there are some connections that are using the port of the NP3, which are wrong. Something's wrong with them. There is some something that are weird. I didn't mention that, and I think it's actually quite important. So someone accessing the PCAP should look at it and should be able to understand that there are wrong strings, and as I've said, we can even apply a filter in order to identify the wrong strings in a period of time, and this may imply that someone is using a fuzzer. So there are more advanced techniques that use different levels of communications that may indicate that a fuzzer is being used. It depends a lot on the dissector and the depth that you want to apply. So here you can see all the wrong strings. So we can see that an attacker is using a fuzzer, and therefore we can realize that some fuzzing techniques are being used in this system. I have another demonstration that I would like to explain a little bit more. So this is another demonstration in order to detect the IEC 104 attack that uses the single command that we've seen before. So this is not related to the demonstration. This is a rule, a man-in-the-middle rule that may be used in IEC 104, and this is the infrastructure that has been set up. So we have a router switch, which is open source. With the Viata distribution, you can create your architecture and do several things. There is a probe with Snort, and this is analyzing the traffic. And then we have the SCADA network and the master and slave areas, which are, in this case, exchanging the IEC 104. And now I want to show you the demonstration. Well, this is more dynamic, and I don't have to explain it that much, but here you can see the EIC 104 strings. So here you have the single commands that I've mentioned before. Here you can see that the value is 45, and well, you need to detect it on the tool, but we already can see that how to identify this type of attacks, for example, a string being injected, or DLL, which is malicious, that is interacting with the process. And, for example, we can realize if there are strings being exchanged in a high frequency. It's not logical to have a person switching on and switching off, putting service and removing service in a very short period of time. So this is not done. This is not something that is usually done. So when someone is switching on and switching off, these are industrial switches, so it shouldn't be frequent. So here we can see the snort. It's starting up. The master and the slave are interacting. There is an opening and closing phase with the different tags that IEC 104 is using. Then we can see how this interacting and sending packages. And at the graphic level, okay, I'm going to advance a little bit because we don't have much time. So here we have the writings. Simulators are being used, and an attacker could modify a DLL and could do more sophisticated attacks. And here we can see that this is part of our platform, the Snorby platform, that allows you to visualize everything that's going on. It takes a while.
Aquí se puede ver, a ver si... No, ya me he colado. Vale. Bueno, estaba aquí, 2D, el 2D.
Okay, D2
el 2D es el, digamos, el 45, ¿vale?
is 45. This helps us to detect a single command because this involves detecting packages and cutting them in order to obtain information that we want to obtain. So we've added a filter here in order to detect that command in a specific period of time. And right now we can see here different pieces of information. there were different requests in a short period of time, and this is how we've detected that problem. And in the end, this is going to let you know that an attacker is injecting traffic or strings or interacting with the system without a permit. And how is Mitre modeling? In Mitre, we have different tactics and techniques classified. So I have this matrix, for example, and depending on the phase in which I am, there are going to be different tactics, techniques, etc. But can we see it in a more graphical way? Yes, with CAT. I think this is clear. You can see the targeting of an attacker, who I'm going to attack, obtention of information of the company, spear phishing with an embedded document, how everything is integrated in order to keep on infecting, infiltration, persistence. I don't want to explain this into depth. I don't have much time and I want to leave room for questions, but I think that this is already quite clear. I don't know what do you think, but this is the whole process, basically. The process, if it's on the internet, there are documents that may explain this in general terms. I mean, I know that you cannot read right now what's writing on the slide, but this is going to be available to you, and if you have any question, you can ask me at any moment. But this is also going to allow you to see if there are different lines of attacks, because there may be two different teams attacking at the same time, and they are not going to be executing the same techniques or using the same methods, and the timelines are going to be different too. So if I'm being attacked in two different directions, I'm going also to know. And also regarding the objective, here we can see the different options that gray energy developers may have done in order to impact on the process. And finally, here I have a website, AnyRun, that provides information on how everything interacts. And as you can see right now, a person may use and bring up a machine, a Windows, and in this case, there was a malicious document that could be incorporated into the tool. In the end, this is a sandbox, and it's going to allow you to obtain quite a lot of information. So here you can see everything that's interacting and everything that's going on. Macros are being enabled, disabled until the infection takes place. Also, you can obtain PKs. You can see the DNAs, if the DNS are malicious or not. You can also get commitment indicators. Although, of course, the tool itself is using them already. The process is under execution, and also something which is quite interesting, which is new, is the tactic and technique part based on Mitre. So in the end, everything that you've seen before is based on these techniques and tactics. So, well, I will try to upload the techniques and techniques as soon as possible to GitHub, because even though Mitre is more oriented towards information technologies, it's true that right now they are also working on that issue. So here you also have some links that may be interesting, links related to projects of some people. For example, the first link is from a project that was launched like the day before yesterday, and it talks about how detecting tactics and techniques at the IT level. And then there are other links that may be interesting at the industrial level. The second one explains how Mitre Matrix teams are focusing on the industrial area. There are also other links about Alexander's presentation. Well, you have many links that you may find useful. And, well, the final demonstration that I had is what I've just shown you. You also have the link. You can check it. You also have the binary. People uploaded many things. And, well, if you don't know the platform, it's quite powerful. And, well, this is it. Thank you very much. I hope that you could understand almost everything I said. Thank you very much. If you have any questions, if there was something you didn't understand, please tell me. Well, first of all, thank you very much for your presentation. I wanted to ask you if you've seen a commitment indicator in malwares related to electrical networks or in industry. I mean, something which is different from common malwares that we've seen lately. Commitment indicator, you mean any weird string or something like that? Well, in this regard, yes, I have, but because that malware is specific, so you may have an indicator that may be looking for a string associated to a DLL, industrial DLL, or maybe there may be some communications that use industrial protocols, but regarding DNS or DNS requests, etc., they are the same. They are the same as the ones used in IT. Are there any other questions? Well, so thank you again. Thank you.